Now that we've discussed the law of reflection and mirror types, we can get into the ray diagrams. So on that note, gather your materials. You need a colored pencil, a regular pencil, a ruler, and the notes packet and practice page we started when we did lenses. There are a bunch of similarities with lenses ray diagrams, but some key differences too. Ready? Let's do this. Remember that the general pattern for all ray diagrams is parallel in through the focal point, out through the focal point, in, parallel out, and then you just draw and describe your image. The main difference between lenses and mirrors is that mirrors reflect light instead of refracting, so when we say out, we mean back in the same direction. We know this is a concave mirror because the center of the mirror is curving away from the object. Draw your incident ray parallel to the axis. This ray then reflects off the mirror through the focal point, so draw it going down and away to the left. The next ray of light goes down through the focal point, then reflects parallel to the axis, so draw it horizontally going off to the left. Now these reflected rays have to intersect at some point, and this intersection shows where the top of the image should be. Draw your image. So when we draw the image, we see that this image is inverted and real, larger than the object was, and farther from the mirror than the object was. The other concave mirror will give you a virtual image, so here are our steps this time. Parallel in through the focal point, out through the focal point, in, parallel out, dash back to intersect. And then draw and describe your image. Notice that our object is closer to the mirror than the focal point. Draw your first parallel ray in, then reflect down through the focal point and away to the left. Draw your second ray up from the focal point to the top of the object to the mirror. Remember that you can't just choose any angle for this incident ray, you have to use the focal point to tell you where it will go. Draw the reflected ray parallel to the axis. Since these two reflected rays don't intersect, dash them backward until they do. Because real light is not behind the mirror like this, we're going to consider the image that we're drawing to be a virtual image. So our virtual image is upright, it's larger than the object was, and it's farther from the mirror than the object was. This is how makeup mirrors work. When you're very close to the mirror, you get an enlarged, upright image of your face. Convex mirrors always give virtual images. Let's work through this. Parallel in through the focal point, out through the focal point, in, parallel out, dash back to intersect. For convex mirrors, the focal point is behind the mirror, where you will get a virtual image. Light can't go through the mirror, so we're using the focal point to aim our light. Here's what I mean. First ray goes parallel in, just like it always does. Now, it's supposed to reflect through the focal point out, but it can't. So instead, it's going to leave the mirror as if it came from the focal point instead. So draw your reflected ray off to the left as if it's coming from the focal point. The second ray of light is supposed to go through the focal point on the way in, but it can't. So instead it aims at the focal point as it goes in, and then it reflects horizontal as normal. Since the real rays of light don't intersect, dash them back to get an intersection point of the virtual rays. Draw your image, and you'll notice that it's upright and virtual, smaller than the object, and closer to the mirror than the object. This is how mirrors on your car, the security mirrors at a store, and the mirrors so drivers can see around curves all work. You get a smaller, upright image of things happening around you. Here's a recap for you. Please pause the video if you want to take notes on this slide, because this is the end.